and foremost, a very warm welcome to today's webinar. Right, a quick introduction to myself. My name is Richard Koh, and I'm the chairperson for the Free and Open Source Software SIG. Right? As part of SCS SIG, we organize a lot of events helping to introduce new technology and interesting ones that will be core to help drive innovation, right, in the space for technology, right, and making our members, right, a lot more aware about what is happening out there in the world, right, and also taking this technology to your enterprises, to your work, that can actually benefit the companies in general, right? So I'm very happy that we have Gabriel and Derek today from Mongodb, right? They're going to share with us, how databases built for the modern applications. As many of you may be aware, right? Companies everywhere across all the industry verticals are all driving towards transformation, wanting to become more agile, right? So building a lot of new applications, looking at leveraging cloud capabilities, right, to make them become faster and more intelligent in the process, right? This new generation of applications also need more advanced technology for their database repository, right? So they need a more modern, right, data platform. And I'm very glad that we have the experts here with us today to share with us a lot more about what are the requirements, requisites, for a modern data platform, and what should you be looking out for, right? And without further ado, right, let me just hand over to Gabriel, right, who is the regional director for Mongodb, to kick off today's session. Yeah.
Okay, thank you. Thanks, Richard. Okay, so let me have a quick introduction of myself. I'm Gabriel Wu. I'm based in Hong Kong, and I'm the regional director of Mongodb across Hong Kong, Singapore, Malaysia, and Taiwan. But even I said I'm based in Hong Kong, if everything okay, I think I will be in Singapore 2 weeks from now. Okay, I'm just waiting for my last step of the approval of the process. Okay, and like what Richard mentioned, Mongo, for a lot of people may think, hey, it's a kind of new technology. Definitely yes, because compared to a lot of, I would say, databases in the market, they all have been in the market for maybe 20, 30, or even 40 years. Because we all know relational database, that RDBMS technology really started almost 40 years ago when we are thinking about how to save hardware cost, storage cost. Okay, today, what we're going to do is to help Derek Chow, our local solution architect based in Singapore, to share with us, hey, how the modern modern applications should think of for the requirement for database to help them to build the modern applications. Okay, so I will help to introduce today's agenda, walk through the agenda, and also have some logistic and also Q&A section to make sure everybody aware. But having said that, let's start with the safe harbor statement. I think for all of you have been in webinar very frequently right now, you all know there's a common statement, so just make sure that we are all aware of. But having said, today's speaker, Derek Chow, is, as I mentioned, our local solution architect. He's based in Singapore, and maybe not a lot of you may are not aware, actually, we have our Singapore office for almost a year. So we are building a team here. We have established more people to support the team, our customer across the region. And also myself, Gabriel, I'm now based in Hong Kong. So a bit of housekeeping. So today's webinar is recorded, and so it could be shared later. And all participants, we put it on mute right now. But in case you have any questions, please feel free to use the Q&A box at the Zoom screen, so that you can feel free to ask any questions, and use the chat in case you have something to say, hey, I can see a screen, I can't hear voice. Okay, you can ask that in the chat sections. And by the way, don't forget to fill out the survey at the back of at the end of our webinar. Okay, once you fill that with some questions, and then there will be a $20 Amazon gift card we will share with you. Okay, now the key content of today's webinar. What is the database for modern application? How we do it? What are the key considerations? I will now pass to Derek Chow, who also start with have a strong application development background. So he will share about, based on his own experience, why you should think of database to handle today's technology, today's workload. Derek, I'll pass to you.
Right. Thank you, Gabriel. So first, very good evening to everyone. Thank you for taking the time to listen in on us. Let me start sharing on what we here at MongoDB think a database for modern applications should look like. And I think it's interesting that Richard started by mentioning a lot of different technologies that many of us relate with when it comes to modern applications, right? And I'm sure some of these will resonate with you, right? Technologies like Kubernetes, Kafka, architectures like event-driven and microservices, agile methodologies. These are surely some of the key technologies or related, ecosystem that you think about when you think about modern applications. And all these technologies, how they really matter, like what Richard mentioned earlier, is the ability to deliver value and deliver fast for your enterprise to your customers. But amongst all these, data technologies is often one of the most overlooked. And that's what we find amongst our customers as we engage with them. And the key reason could be this, like what Gabriel also mentioned, many of our customers are still focusing on using technologies that was invented 30, 40 years ago, when storage was actually big, bulky, and expensive, like what you see here in this old image, right? And we know that in the relay race, in any relay race, you are only as fast as the slowest runner. And if you are doing a refresh of the technology, you are doing a modernization or transformation, but you still have pieces that are critical, but slowing you down, then that would be where you will be fastest. That will be the only speed you can get to, right? And so this is why we believe that developers' biggest problems today are still data problems, right? They could have all the Kubernetes and they could be doing all the microservices, but they are still using rigid, complex relational models, where when they had to make a change, it would take maybe weeks just to get the process to get through to make a change to a database. For example, to add a column or to change the length of a current column, for example, right? And the funny thing is that the code that is written to handle that is probably written much faster than making that change to the database itself. And when they finally get that change through, you'll find that the data that they rely on are running on monolithic, fragile relational systems that cannot deliver the kind of resiliency and scale that is demanded by modern applications today. Right? Think about running microservices stateless on Kubernetes that can scale theoretically infinitely, right? And how is a database that is running on a more traditional manner going to handle that kind of scale and resiliency? And for the more adventurous developers, they'll try to make their way around finding different NoSQL technologies that they hope to leverage on. But many of them will find that these NoSQL data stores are really good at one thing. For example, to deliver queries really fast. But they discard other essential developer functionalities like the ability to do complex queries. And those are some of the problems that we exactly see at our customers right here in Singapore. And so this is why MongoDB is designed as the database for modern apps. It was first started by our founders really to overcome the limitations that they faced when they had to deal with RDBMS when they started to their work, right? And so what really makes MongoDB so great for modern applications? So to start, MongoDB believes in the document model, and we have the MongoDB query language, MQL, which combined together offers the fastest way to innovate. And MongoDB with a single code base can run on something as simple as your local machine, it could run on a server, it could run on private public cloud, or it could be stretched across a multi-cloud infrastructure that runs globally to give you that freedom and flexibility and confidence to run it with high availability, to run with scalability. And the last part that is important for modern applications is that for your data, you need to go beyond just the database. And that's where MongoDB is going, right? MongoDB today is not just the database, right? But we are a larger application data platform to offer unified experience for leveraging data on your modern apps. And so now let me dive slightly deeper into each of these three pillars. So how does MongoDB help developers to innovate fast? And I've spoken about the document model, but first let us look at what developers have to deal with today, and that is the tabular data model. That's on the left side. If you look into the diagram there, you can identify very easily that it's a customer profile. A customer profile that requires a relationship to an address table because of the need to have multiple addresses, and a lot of other peripheral relationships like phone numbers, city, country. And what this really means that to pull out a complete customer profile would require many joins. And this really makes it, firstly, hard to code. And I'm sure a lot of developers will be doing trial and error on the SQL statements. And when that is done, you'll find that the performance is usually less than optimal. But on the right-hand side, that's where the MongoDB document model really shines. In that single JSON object, you get the entire profile of the customer. And we are able to easily represent multiple addresses with just a single array, right? And what is more important is that as you need to make changes, it's flexible. Just think of it in, if you go back to RDBMS and you look at the address table, the address has a limitation of 50 characters. That might work fine for today in the market that you're in, say Singapore. And as you expand to Malaysia, to other parts of the world, Indonesia, US, you'll find that even something as simple as an address can vary quite wildly across the world. And how do you accommodate that easily? So to expand to another region, to another country, you first have to even make a change to something as simple as a customer profile. And that's a challenge that developers deal with. And even after dealing with that, you have to deal with additional requirements. And now your business says, we need to store more than just one phone number for our customers, because our customers today can own multiple mobile phones. They will have a work number that you can dial in, right? So how do you add that easily without having, again, to go through a change process, right? To go through that complexity that can take weeks. And MongoDB offers that by letting developers add new fields dynamically at runtime. Another complexity that developers have to deal with is ORM. And it actually creates some kind of divide between DBAs and developers because they see the data differently. You can see that developers actually see data in the form of objects that they deal with in their code, while DBA sees it in the form of the tables that they manage. Now, this is where the developer have to actually create this mapping between their objects to multiple tables. Surely there are Hibernate, Spring Data kind of technology that tries to simplify this whole process. But as you go into the kind of complex relationships like the many-to-many and having to merge multiple tables together, it gets harder, right? And it just means that there's additional code you have to handle. And with MongoDB, this is where we want to help developer to do this in a direct manner. You persist your objects that are in your code directly the same way into the database without any need for mapping one-to-one. It makes it easy for everyone to understand as well, right? And so just to sum it up, The document model helps you to remove the need to use an ORM. It easily helps you to represent data of any structure, including relationships. And that's an important part, right? Because for MongoDB, it started as a NoSQL database. A lot of developers associate MongoDB with unstructured data. But that's not the case today, where we have evolved to handle transactional workload and relationships really well, right? But with this, it allows you to modify the schema at any time, and we continue to support over 20 different JSON data types. And it comes with a whole ecosystem of drivers that consistently help you to interact with your data through your code. And this brings me to the next part, where we are now able to store data. That's great. But how about retrieving data? And when we talk about retrieving data in the modern apps world, it's no longer limited to, here's a JSON, get it from me. But now we have to answer questions like geospatial related questions, graph relationships, file storage in terms of media, PDF, event-driven architecture to capture change state in data, or even to do text search across your entire set of documents that we call a collection, right? So we are no longer limited to just simple queries. And these are examples of what the MongoDB query language can do for developers, right? To answer beyond that simple question that you see in expressive queries. Find anyone with a phone number that starts with this. That's simple. But how about geospatial, where now you have to find offers for a customer that's standing at a particular location, and you want to find offers for him or her that is 500 meters away from him or her, right? So that kind of geospatial query, you can't easily do it with regular RDBMS. And what about text search across all your data to find tweets that mention your company within the last 2 days? Or what about a graph lookup for people within 3 degrees of separation from a certain customer? So these are examples of what MQL can do for you. But MQL goes beyond that, in that we also provide the aggregation framework as part of MQL to offer advanced data processing pipeline that helps to transform your data and to answer analytical questions beyond those that you saw, right? For example, we have orders table, orders collection over here, right? In the orders collection, we have 4 documents, right? 3 of them has a status A, if you can see it on the screen, right? And 1 of them has a status D. So with the aggregation pipeline, we start with a match stage, right? And in the match stage, we are trying to match statuses that starts with A. So customers with that status will appear in the output of the match stage, which now becomes the input to the group stage. And in the group stage, what we're really trying to do is to group the customer documents according by their ID, and then do a sum of the amount they spend to find the total spend. And so that's what you get as the output. And you can see that the output is actually quite different from the original data, where it's now simply an ID and a total field, right? Which both fields did not exist originally. And you get a wholly different representation as an output that becomes more useful. On the same set of data, you get a different representation for your applications to deliver and answer questions for your end users, right? So with MongoDB documents, we remain fully indexable, and we go beyond the typical primary and compound index. Because we support arrays, we have multi-key and wildcard indexes for supporting arrays. We have text indexing and geospatial indexing. And we also have unique index features such as TTL, time to live. Basically, an index where we monitor the expiration time of a document and delete it automatically when it reaches the time. So this is really useful for when you have to keep, say, 7 years of data and you need to archive data to a different source, right? After 1 year, for example. And you could run that job to archive automatically. And then now you have a TTL index to delete away the documents that you no longer need. Or we could have a case-insensitive index to support text search, which is case-insensitive. Or we could do a sparse index that only index documents that contains the given field, so that we do not waste space to have indexes that are not useful, or to and to actually improve the efficiency of the search. Right. As I mentioned earlier, by now MongoDB, actually since many years ago, like 4 or 5 years ago, we have already started to support transactions. And if you look at a single document by itself, as I mentioned, is already relational. So by virtue of persisting a document, you are already doing a transaction. But we have extended that to be able to do multi-document transactions, where the transactional boundary is set between multiple documents from different collections in an all or nothing commit fashion, with the ability to roll back. And that's all fully ACID, right? So just to sum up, I hope you have seen the MongoDB document model and MQL together, what they mean for developers to be able to be more productive when creating their modern applications. So now that you're there, the next part is how do we run our data, right, for our modern applications anywhere confidently. So as I mentioned, same code base, one single code base, same API, same tools, no matter where you run them, whether it's on your local machine all the way to the public cloud and your private cloud, or even a hybrid model, and all the way to a fully managed cloud service by MongoDB that we call MongoDB Atlas. So with MongoDB Atlas, it's self-service and fully automated with elasticity, HA security all out of the box, right? And if you so wish to run this on your own private cloud or your own data center, we also provide you the tooling in Ops Manager to do so. Ops Manager providing automation, monitoring, alerting, backup, restore, so on and so forth, right? And we also provide an enterprise operator for Kubernetes. Like I mentioned, Kubernetes is a big thing now. Everyone is going into containers. And so with MongoDB, you can actually run your database as containers in Kubernetes. So to run your data confidently, it must be highly available. Because even if while your app runs, if your database is not available, then essentially your app is not present. So with our distributed HA architecture that we call a replica set, we are able to support self-healing capabilities that typically fails over in 5 seconds or less, and that's a configurable value. So how does that self-healing happen? You see in the diagram on the left-hand side, there's 3 nodes. It's a minimal 3 nodes up to a 50 node limit, right? But minimal 3 nodes with 1 node that's always designated as the primary, and the remaining nodes that are secondaries, right? Read and writes are by default always going to the primary node, right? And when a writes happen to the primary nodes, they are replicated to the secondary. So if you start with a 3-node replica set, you are always ensure of having at least that 3 copies of your data. That's not including the backup mechanism that we support and I'll talk about later. Right? So you will be really sure that your precious data is always there. And with these 3 nodes, it fails over in 5 seconds or less, right? And that's at the server side. On the application client side, we provide the MongoDB driver, which comes with a feature that's called retrievable reads and retrievable writes. With retrievable reads and writes, what this means is that it's able to, in real time, find out which node currently is the primary node. And if the current primary node fails, it's able to know that. And any in-flight queries or writes that doesn't get through, we will retry it on the new primary. So this amounts to the end user not experiencing any downtime at all, right? But at most, a 5 seconds kind of slowness that is more tolerable than, say, a server 500 error, right? And this architecture is useful for not just that, but it is also useful for disaster recovery, where you can spread the nodes across data centers. It's useful for maintenance, where you can do rolling upgrades within minutes and have zero downtime all at once. So that 3-node architecture is not one that is used for scalability. To scale your database, MongoDB adopts sharding. And to that end, we do it in an automated fashion. So let me explain a little bit more. Sharding is the process where you take your entire data set and split them into multiple subsets and have each subset actually reside on their own replica set, right? So what you see here, shard 1 is a replica set, shard 2 is a replica set, all the way to shard n, each of them with a subset of the entire data space, right? And MongoS that you see that is added into this diagram on top of the replica sets are actually the query routers. So what MongoS does is that when an application wants to connect to the cluster, instead of connecting to the shards directly, it connects to MongoS. MongoS will take the query or the writes and decide whether it has to just go to shard 1 or it has to go to multiple shards to gather the data and merge the data and return it to the application. In the case of a write, it will also know which shard it should go to. And for writes, you should just have to go to one shard. So the net effect is that with such a sharding architecture, you are able to handle higher data volume and you are able to handle higher throughput because of concurrency, right? And the best news for developers is it's fully transparent to you. For developers, the only change you need to make is a change to the connection string. Like I mentioned, you no longer connect to the replica set, but you connect to the MongoS. There is no change to the data access logic, right? Because the whole sharding capability, as I mentioned, is transparent, is fully automated. To run your data confidently, you need to be sure that your data is secure. And we have seen lately a lot of news that has arisen out of technologies that were running on the cloud, right? But with MongoDB, you can be sure that the most fundamental securities are all covered. Authentication, authorization, auditing, encryption, all these are standard table stakes that we provide out of the box for our enterprise customers. But I just like to mention, with encryption, we have something that we call encryption in use that is on top of encryption in flight and encryption at rest. For encryption in use, we have a feature that is called client-side field level encryption. And essentially, it helps developers automate the need to further encrypt specific fields. For example, personal identifiable information that we call PII. If you have to further encrypt PII, you could do it automatically on the client side, of course, with some configuration, right? And then ensure that that data, before it even reaches MongoDB servers, those PII fields are already encrypted. And when it lands on MongoDB, the encryption at rest actually offers that second layer of encryption. So it's encryption on top of encryption. And what this means is that if for some reason a production engineer gets access to the data by a misconfiguration, for example, even that production engineer is not able to see the data, the exact data values, but he will see something that has already been encrypted on the client side. Right? And for customers of our MongoDB Atlas managed service, you actually get your dedicated VPC and with private network peering to let your applications connect directly to this dedicated VPC without going through the internet. Right? And my last point on giving you confidence to run your data on MongoDB is the ability to, on top of the three or more replicas that you have, the ability to back up and restore your data down to a minute's granularity, essentially giving you an RPO of 1 minute or less. So what you see here on the screenshot is the UI in Atlas for you to specifically choose right down to the minute, if you can see, right on the right-hand time UTC box. That's where you indicate the hour and minute that you want to restore your data to give you that kind of RPO. Right. So I've talked about both the developer and the operational aspects of MongoDB. Now let me go to MongoDB Atlas, which, as I mentioned, is more than just the core database, but a data platform, specifically application data platform, to help developers gain productivity over just the core database. So Atlas starts with, of course, the MongoDB core, which I have been talking about, transactional with flexible data model with a distributed architecture. That stays the same in MongoDB Atlas. But now that core is fully managed by MongoDB, running on the public cloud, AWS, GCP, Azure, that you know, over 80 regions. And in a few minutes, I'll be doing a demo to show you how we can actually do a true multi-cloud setup in Atlas within minutes. Right. It also provides other features such as auto-scale and performance advisor. But like I said, we are more than that now. We have a mobile database in Realm with the ability to do offline storage. And when it gets back online, to sync automatically back to your database in Atlas with built-in conflict resolution. With that is the same algorithm that's used by Google Docs for real-time collaboration. We also have MongoDB Charts, which is visualization for data that resides on MongoDB. And why do we have to build a new visualization tool? Because what you get out there in the market, most of them support only tabular data, which is what you get from regular RDBMS. With charts, the key difference is the ability to visualize your data in native MongoDB document model and leverage on that richness, which include nested documents, arrays, so on and so forth. There's also a full text search capability, which is essentially a built-in Lucene engine on top of your data to give you the ability to do full text search without having to do ETL to build a separate database, just so that you could have search capabilities in your modern application. And then there's data lake, which is to federate your other data that may be sitting in S3. Federate together with your data that is in MongoDB Atlas using a single MQL MongoDB query language to be able to, in real time, query and get response, an aggregated response that comes from both MongoDB core and your data in AWS S3. So as I mentioned, all this is running on multi-cloud infrastructure deployed on GCP, AWS, and Azure. And there are integrations that help you to get more out of your strategic investments, such as infrastructure as code, where we have Terraform provisioners for Atlas. We are able to run on Kubernetes. As with monitoring, we are able to integrate with tools like Datadog, New Relic, and more. Right, before I go on to the demo, just want to share some customer success stories. In this region, we have ANZ Bank, who needed to deliver a critical payments platform, where they have to process 10 million database transactions a day, and their legacy infrastructure couldn't keep up. Right? It was unable to scale, it was unreliable, causing them to even have to speak and report to the Reserve Bank. So MongoDB came in and built a highly available and scalable architecture for them, right? With a 5-node replica sets that's across 3 data centers. They made use of the flexible data model to actually support a bigger variety of payment types. And the net positive business outcome is a 5.9 availability and capturing payment status 60 times faster and getting a 10 times storage savings annually. We also have a customer that was very successful in the public sector. And this is the city of Chicago, where they face the problem of having data siloed across multiple city departments, right? 30 plus to be exact, 7 million pieces of data per day. They needed to aggregate all of this together in order to build a single view of the city operations. And that's where they leverage the flexible data model of MongoDB and our rich analytic features. The aggregation framework that I spoke about earlier, together with geospatial indexes, in order to find out, for example, which part of Chicago city that needed help, right? And the net result is, as I mentioned, a single view of the city's operations, new predictive analytics systems, and 450 data sets that have been published to the public to spark even further innovation. So with this, let me move on to my demo. So what you're looking at on the screen is MongoDB Atlas. And I just want to show you the process of spinning up a new MongoDB cluster. When you spin up this new MongoDB cluster, firstly, you might think, how can I get this across multiple clouds? So we have a unique capability to span your nodes. As I mentioned, a minimal replica set is 3 nodes. So we have this unique capability to span your 3 nodes actually across all 3 providers. So you're looking at me adding more regions and providers. So first one is AWS, then we have GCP, and then we have Azure. And we want all of them to be in Singapore, where we fortunately are in a good place to have all 3 cloud providers build data centers here. And I just want to dedicate 1 node each. And that's how I will run my highly available replica set, not just across regions. I could change them to be not in Singapore for sure, but I could get that high availability that is across different cloud providers as well. On top of your regular nodes, we have the ability for you to add read-only nodes. For example, in a region that is far away from Singapore, so that you can reduce the read latency of your customers that are now out of Singapore. And the same multi-cloud capabilities is available for you. So I can add as a third one, Azure, to run in, say, Paris. And you can see how, if your customers are located in another part of the world, can benefit from having faster access to your data. We have the ability to do analytics, but if your analytics were running on the same nodes that are doing your transactions, receiving your reads and your writes, surely they will impact the experience of your end customer. So this is where we also have the ability to spin up additional analytics-specific nodes, again, across different cloud providers in different regions, if you so wish to. And these nodes will be dedicated to running analytical workloads that tend to be more compute intensive and memory intensive at the same time, depending on your data set, right? Without affecting your transactional workload that are running on these servers. And now this is just a replica set. But how about if we want a global footprint? We have the ability to help you easily build global clusters that can give you global performance. Each of these is a shard across, say, in this case, I chose just 3 regions, Americas, EMEA, and APAC. And each of them, as you see, we have the 3 zones here. Each zone, you can build the same infrastructure that runs MongoDB that I spoke about just now across multi-cloud. Just to show you that example very quickly. And over here, you can choose Singapore. Right, in here, Singapore is not available, but we can choose other. Right. So after deciding where your nodes would sit and what kind of workload they will take on, you can now decide on the size of your machines that will run the clusters, that will run your workload, right? And we have the ability to do scaling. So choosing a larger machine over here, I have the ability to say, I want my cluster to be scaled down if the load is low. And I want my cluster to have the flexibility to scale up. So this is for individual nodes where the scaling allows you to burst when in situations of sudden spikes. But this is not the best way to do persistent scaling, which is through the sharded architecture that I spoke about earlier. This is added on to help you to actually manage sudden spikes in traffic. For example, dealing with a sudden a holiday or a certain event, right? There are additional settings like choosing the version of the MongoDB that you want to run, turning on continuous backup with the ability to do restore right to the minute, and to bring your own encryption key, for example. So finally, after you create a cluster, you will see what I have here. And just to go back, just to show you, it takes, of course, a few minutes to do it. But once it's done, you will get this view where now you are able to click into your cluster, and you'll find all the functionalities that I spoke about earlier. The ability to do monitoring and alerting in your database, the ability to look into your data through the collections, where it will retrieve all your databases and let you inspect your data, your indexes, and let you to do a visual tool, and to give you a visual tool to do aggregation, right? There's search functionality, where over here, you are able to build your search indexes. There's performance optimization tooling provided in the form of here, a profiler, to help you understand slow queries, and a performance advisor to suggest indexes if they are needed, or to suggest for you to drop indexes if in the event they find that they are not needed, right? And also recommendations to improve your schema as required. So there are more features, and in the interest of time, I will be moving on to the Q&A, but the additional features here include backup that I spoke about, online archiving, which is to archive data that reaches a certain date onto cheaper storage. We have MongoDB Realm at the top. Once you click on it, that will bring you to the ability to do offline mobile database and synchronization back to Atlas, and Charts, which is the visualization piece.